Good afternoon, dear students. Today we are going to see the topic electroencephalogram (EEG). Okay. In the last class we have discussed about electrocardiogram, that is ECG or EKG. Okay, the other name of ECG is EKG. So today we are going to study about electroencephalogram, which is used to measure the activities, that is activities of the brain. Okay, that is just measuring the brain signal, that is the electroencephalogram. First, electroencephalography. What is electroencephalography? It is just the study of the electrical activity of the brain, that is called electroencephalography. Then electroencephalograph. What is electroencephalograph? It is the instrument by which the electrical activity of the brains are recorded. That is the instrument which records these activities of the brain, that is called electroencephalograph. Then electroencephalogram. What is electroencephalogram? It is the record or graphical registration or representation of the electrical activity of the brain. That is just the record of the graphical representation of the electrical activity of the brain. These all comes under the EEG, that is electroencephalography, electroencephalogram, electroencephalograph. Okay. Okay. This is a EEG waveform symbol, EEG waveform. Okay. So this is generated by the neurons of the brain. These waveforms are generated by the neurons of the brain. The normal typical bandwidth of this EEG waveform is 0.1 to 100 Hz, and the typical amplitude range is 10 to 100 old. And the waveform is highly random waveform, just in the random waveform. That is, these brainwaves are irregular and no general patterns can be discerned in this ECG. However, at other times, distinct pattern will appear. So, in various activities, various types of EEG waveform will be generated. Okay. There are 3, 4, 5 types of wave, that is gamma wave, beta wave, alpha wave, theta wave, and delta wave. These are the normal waveforms. Okay. And the range of this gamma wave is greater than 40 Hz. This first figure shows the gamma waves. Okay, so this is active when the brain is hyperactive. That at that time this gamma wave is active. Okay, when we are the brain is very active when we are doing some work that we like, right? So that at that time this wave is called gamma wave, and the frequency of this is greater than 40 Hz. Next one, beta waves. Beta waves frequency ranges from 13 to 39 Hz. It is mainly during if we are engaged in a conversation with some others. At that time these waveform will activate. Okay. Then one, alpha wave. This alpha wave have frequency of 7 to 13 Hz, and it is mainly occurred during when we are in a very relaxed disposition. This is the alpha wave occur. Okay. Then theta wave. That is the frequency is 4 to 7 Hz, and this is the theta wave. This figure shows the theta wave. And it is during the sleep with a dream, while we are dreaming this wave is active, that is called theta wave. Okay. Then delta wave, that is when we are in deep sleep and not dreaming. At that time this delta waves will occur. Normally it is during when it is given some anesthesia or something like that, this will happen. Okay. Delta wave, deep sleep and not dreaming. The frequency of this delta wave is less than 4 Hz. So what are the 5 types of wave normally in this ECG? Gamma wave, beta wave, alpha wave, theta wave, and delta wave. Okay. Next, the ECG waveform. Now, what is the purpose of this ECG waveform? Just to identify the diseases that happens in brain, that is brain tumors, epilepsy, if there is any sleeping disorders, brain death, consciousness, etc., are measured by using this EEG waveform. Okay, we know this is a random waveform and we are not able to predict the signal type. Okay, so during this awake condition, the first waveform generated during the light sleep. If we are in light sleep, this types of waveform arise. Then if we have a sleep with the rapid eye movements, okay, at that time this type of waveform occur. And if we are in a deep sleep, this type of waveform occur. And if cerebral death, what is cerebral death? Our heart and circulatory system will function and the brain is not working, that is the cerebral death state. Okay, so our brain death, at that time this type of waveform occur. And in epilepsy, this type of waveform occurs. See, these are the various types of brain wave during some disease or condition. Next, we are going to see in detail about 10 to 20 electrode system. What is 10 to 20 electrode system? Okay, this 10 to 20 electrode system, normally what is the purpose of this electrodes? These electrodes are mainly used for the measurement of various signals that is coming from the brain. Okay, so this 10 to 20 electrode system is also used to measure this potential. Okay, so how we are placing this electrodes? So 10 to 20 means there will be some positions, 10, 20. Okay, 10%, 20%, that, so the name 10 to 20 electrode system. So normally for this, silver or silver chloride electrodes are used as the surface electrode in this setup. So normally in our head we are placing this electrode, right? So for this purpose, that is in the head, it is we are placing electrodes, so that electrode is called surface electrode. And it is these electrodes are made up of silver or silver chloride. Okay, so on the scale, the distance between two electrodes are given as 10% and 20% of the distance between specified point. So from some particular point, the distance is 10% or 20%. Okay, so there will be 2 points, this Nasion point and this anion point. Okay, so this around this point we are connecting. Okay. These Nasion and anion are the two reference point, okay, near the earlobe of the human. Okay, this now along the head, through the top of the head, this Nasion distance is splitted into 5. Okay, divided into 5 points. Okay, and from the 10%, 20%, 20%, 20%, 20%, again back to 10%. So the Nasion anion distance where the vertex is measured and 3 electrodes are placed, thus one in the frontal, this is the frontal portion. Okay, and this is in the central portion, and this is in the parietal portion. These are the 2 portions where we are placing this electrode. Okay, have you all understand? What are the 3 portions? Frontal portion, central portion and parietal portions. These are the 3 portions along the head. Okay, that we'll see in the next slide. Okay, they are placed at a distance 10. Okay, that I will see. Now, similarly, the Nasion anion distance is measured along the temporal lobes, and 5 electrodes are placed as 2 in frontal and 2 in temporal and 1 in occipital lobe. This is the 2 in frontal, 2 in temporal and 1 in the occipital lobe. This is the figure shows. Okay, this is the where we are placing the electrodes. These are also placed at 10%, 20%, 20. That is the distance. Okay. Lastly, on the peripheral of the circle, remaining 6 electrodes are placed. Okay. This remaining 6 electrodes are placed, 2 in frontal, 2 in central, and 2 in parietal. Okay. So this is the this electrode, 2 frontal electrodes. So one on this right side and one on the back side of this, that is right and left side. Okay, in the central also we are placing one here and one on the back side. In the parietal portion also we are placing one on here and this next on the back side of that. These are the position of electrode and how we are placing this electrode. Next, this figure shows the 10 to on the top view of our head. Okay, this is the top view of our head. In this figure, the position of the scalp electrodes are indicated. This is the position where we are placing the scalp electrode. Normally 21 electrodes are there. In this figure we can see the 19 electrode. Just wait 1 minute, I will discuss. Okay. So if we want to place these electrodes, we already studied about the electrodes, right? So what we have to do for placing the electrodes, can anyone say? Before the placing the electrode, we have to clean the portion, right? So here also, before placing the electrons on the scalp, we have to clean the portion. Okay, so before the placing the electrode, the scalp is cleaned, lightly abducted, and the electrode paste is applied between the electrode and the skin. By means of this application of the electrode paste, the contact impedance is less than 10 kilo ohm. Normally disc-like surface electrodes are used. Okay. In some cases, needle electrodes are inserted in the scalp to pick up the ECG signal. So normally for measuring the open surgery and all, also various types of depth electrodes we are using. So in many cases we are using the different types of needle electrode for the measurement. So okay, let's see how these electrodes are marking. I have to concentrate clearly. Okay, 1 minute. No. Okay, let's continue. Okay, so listen properly. Okay, you have to understand what I am saying. Just look at this figure. Okay, so draw a line. This is the NAS ion. Okay, this is the NAS ion, this is the ini ion, this is the left ear, and this is the right ear. Okay, have you understand this 4 points? NAS ion, ini ion, left ear, and right ear. So we have to first draw a line from the skull, this NAS ion towards this ini ion. Okay, towards this line we are drawing a center line, that is the point F2, C2, P2, that line. Okay, that is the line from NAS ion to ini ion. Then we have to draw a line connecting left ear to the right ear. So we get a central point, this one. So that is the place where we are placing the first electrode. Have you understand? So first we have to draw a line NAS ion to ini ion, then to left ear to right ear we get a central point, and this point we are placing one electrode, that is called C2, which is at the midpoint of the distance between the NAS ion and ini ion, the distance between the auricular points. Okay, next, then we have to mark the points along this NAS ion to ini ion distance. Okay, along this distance we have to mark 10%. When we mark 10%, we get this place 20%, 20% distance, 20% distance, another 20% distance, then 10% distance. Okay, so these points are marked as these points where this is here we are not placing an electrode, but we have to mark it as FPZ. Okay, just a reference point, just a point. Okay, FPZ, then F2, then C2, then P2. Okay, then the last point is OZ, just as a point. Okay, just have to note it. Okay, have you understand this point? From nasion to anion, we are splitting it into five, but we are placing the electrodes only on three positions: one on the frontal position, one on the central position, and one on the parietal position. Hope you understand. Similarly, on this left ear to right ear. Okay, from this left ear to right ear, you have to split that. That is again 10%. We are placing T3. Next, along the 20% distance, we are placing C3. Next, along the 20% distance, we are placing C2. Next, C4. Next, T4. These are the distance. Okay, along the ear side. Okay, that is along the preauricular point. That is, the odd numbers T3, C3 are placed on the left side and the even numbers are placed on the right side. So next we have to measure the distance between FPZ. Where is FPZ? Here we are placing the FPZ, just a point. Okay, and OZ here. Okay, along the great circle passing through C3, that is this. Okay, okay, so that is nasion, left ear, anion, that circle. Okay, nasion, left ear, and anion. So again we have to split it into 10%. We are placing FP1 electrode. Next, along the 20% we are placing which electrode? F1 electrode. Then along 20% T3, then T5, then O1. Okay, have you understand? Similarly, in the next side, opposite side, nasion, right ear and anion, we are placing the next electrode, that is O2, T6, T4, F6 and FP2. Have you understand these points? Next, we have to measure the distance between FP1 and O1. FP1 and O1 along the circle passing through this C3. Okay, along this circle passing through C3. I hope you understand. That is FP1, F3, C3, P3. Okay, so here we are marking the point as 25% interval. Okay, till now we studied about 10% and 20% in 20%. Here we are marking as 25% interval. These points gives the position F3, C3 and P3. Then repeat this procedure on the right side also. Here we get the points F4, C4 and P4. Then check that F1, F3, F2, F4 and F6 are the equidistant along the transverse circle. So this is the equal distance. Okay, these all have the equal distance which is passing through the F1, F2 and F8. F1, F2 and F1, F2 and F8. Okay. Similarly, check that T5, this T5, P3, P2, P4 and P6 are equidistant along the transverse circle passing through T5, P2 and T6. These are the various positions of electrodes and how we are placing this electrode. Hope you all understand. Okay, after watching this you just have to go through this one. Okay, first you have to draw this figure in a notebook and then you have to read this. Okay, you will understand the concept clearly. Okay, where we are placing this electrode when we are measuring the brain signal. Okay. Okay. Next, we are going to see in detail about what ECG EEG recording setup. Okay, it consists of EEG recording setup consists of what? Consists of 8 channel selector, differential amplifier, filter, display, signal processing unit, output unit, calibration unit, and tactile circuit. Okay, normally what about the number of electrodes in a brain for measuring the brain signal? Normally it consists of 21 electrodes, right? So here in this figure we see only 19 electrodes. So one electrode is placed on the two ears, that is act as the reference point. So the electrode that is placed on the left ear is the reference electrode for left brain, and the electrode that we placed on the near the right ear is the reference electrode for the right brain. Okay, have you understand? The electrode placed near the right ear acts as the reference electrode for right brain, and the electrode placed on near the left ear acts as the reference electrode for the left brain. Okay, so normally how many electrodes are there? 21 electrodes are there, and these electrodes are connected to the 8 channel selector. Okay, 8 channel selector. The electrodes are attached to the channel selector in a group of 8 called a montage. That is, here in this we are connecting this 8 electrode as a group just to connect to the channel selector, and this 8 group of 8 electrode is called as a montage. So this is 8 channel electrode. Okay, then we are passing the signal from 8 channel selector to the differential amplifier. Okay, this differential amplifier is made up of preamplifiers. What is that? Preamplifier. It is mainly used to reduce the noise. That is, there will be a 50 hertz of interference as may be present in this signal due to the 50 hertz noise is created due to the AC interference, and it is reduced by using the differential amplifier, which acts as a preamplifier with 80 decibel of common mode rejection ratio, and it also uses a 50 hertz of notch filter. Then the output voltage from this amplifier is either be applied directly to the 8 channel display through the filter bank. Okay, here there is a filter bank. This filter bank consists of a low pass filter, high pass filter, and band pass filter, which is used to remove the noise from various brain waves. Okay, so what is the use of this filter? Just also used to reduce the noise from various signals. So the output of the differential amplifier is again connected to the signal processing unit. Okay, then for the further processing it is given to the display unit. Okay, to record the potential generated from the sensory part of the brain, the output unit is connected to various stimulus. Okay, that is audio stimulus, visual stimulus, and also to the touch stimulus. It also measures the time delay between the stimulus and the response from the brain. So suppose if we want to do a thing, means if the information is passing to the brain and brain is given back the response, right? So if there is any time delay, okay, that also will be measured here. Okay, have you understand this? Okay, and the output, it is recorded using pen recorder or CRO. Here normally for this measurement we are using 3 modes. Okay, unipolar mode, average mode, and bipolar mode. What are the 3 modes? Unipolar mode, average mode, and bipolar mode. In this unipolar mode, the potential of each electrode is measured with respect to one reference electrode. That is, we are measuring the potential of each electrode. Normally how many electrodes are there? 19 electrodes other than this reference electrode. So the potential of each electrode is measured with respect to one reference electrode. Okay. Then in the average mode, the potential is measured between one electrode and the average of all other electrodes. So in this average mode means we just need the measurement only one times, that we are taking this reference electrode, okay, the between one electrons and average of the all other electrodes. Then the last one, bipolar electrode. Okay, this using this bipolar electrodes, the potential is measured between the successive pairs of electrodes, that is the electrodes that are placed nearby, okay, which are closely spaced. So the potential is measured along that. Okay, these are the three modes. I have to study this, it's important for 2 mark question. Okay, so next application where we are using this ECG wave, ECG, okay, EEG. It is mainly used for epilepsy diagnosis, anesthetic level, brain injury, monitoring during surgery. These are the main applications, okay, where we are using this, when we are using this EEG recording setup. Then EEG electrodes. What are the types of electrodes that we are using in this EEG? Okay, this transforms the ionic current from the cerebral tissue into the electric current, which is used in ECG pre-amplify ionic current to electrical current. Normally 5 types of electrodes are using in this, that is scalp electrode. It comes under this, it is a silver pad, disc or cup electrode, stainless steel rod, it may be a chloride, silver wires. These all comes under this scalp electrode. Then spheroidal electrode. Okay, next nasopharyngeal electrode, electrocardiographic electrode, and intracerebral electrode. These are the types of electrodes just for the measurement of EEG. Okay, hope you all understand the topic electroencephalogram, and if you have any doubt you can comment or WhatsApp me. Thank you.